L-DIH Talk webinar, to this new episode. So first of all, you're used to it now. Let's do a bit of housekeeping. First of all, you have to know that this webinar will be recorded. Then you'll have the ability to chat with us through the panel that you'll find at the right of your screen. You'll also be able to ask questions, so please clearly separate your discussion from your question. It would be easier for me to moderate and also to not miss any question that you would like to ask to our nice speaker of the day. We will do 2 polls during this webinar. So this polls will be done via a dedicated tab, still on the right of your screen, and this tab is called Interactivity. So, welcome everybody, welcome to this new episode about supercomputing. So, supercomputing can deliver multiple benefits to manufacturing companies, and today, in partnership with Supercomputing Luxembourg and the National Competence Center for Supercomputing, we'll host this webinar to see what are the multiple benefits that supercomputing can bring to manufacturing companies. Surely a lot of you are wondering, is it realistic to apply supercomputing in manufacturing and particularly in SME? Because as you may know now, the DIH, Digital Innovation Hub, as one of its mission is to help SME particularly. And we explore that into this webinar. I don't want to spoil anything about supercomputing in manufacturing SME, but surely some of you will be surprised and will be at least enlightened on how supercomputing could help these companies.
And my connection will be a little more stable. But basically, the introduction from Alban was what the benefits and the general approach of supercomputing is. And right now, I'm about to give you an example how we as a startup are using supercomputers or have been using supercomputers in order to transform our business model, as well as increasing the effectiveness and the efficiency of a production manufacturing company in their warehouse. So after I was introduced, my name is Lukas Kriete, and I'm one of the 3 founders of the Karlsruhe and Berlin-based startup Kimono, which has the mission to empower more people to make use of AI object detection. And right now, I'm presenting the results of one explicit use case that we were dealing with in an EU-based or EU-financed project from the EuroCC and the Digital Innovation Hub in Germany. And the title of the experiment is AI Platform for Automated Training of Object Detection Models Based on CAD Data. So quite a long name, but the basic content of the experiment was to boost the use of AI vision applications. So AI vision, what explicitly does it mean, and why should we boost it? So basically, there are a lot of challenges in industrial processes where the visual feedback or visual inspection of certain objects or certain process steps are necessary. And by automating those steps, by using a computer, those can be made a lot more effectively, and also an assistant makes those processes a lot better. So basically with AI, there are new applications possible, and like visual inspection applications are a lot more usable at the moment. And some examples are like the real-time inspection in manufacturing processes, where you can identify errors, or the automation of repetitive tasks like documenting or like identifying objects, and also detecting potential failures in machinery or products, and therefore drastically enhancing the safety. So for example, like in critical infrastructures like airplanes or like elevator systems. And these are just some examples. There are a lot more applications where AI vision applications can help, and where the use is beneficial. And most or many companies also have identified those benefits, or at the moment at the step where they see that it might be helpful. But the question right now, and which we were dealing with during our experiment, is why it is not as widespread as you would expect, and especially from the perspective of an SME, why aren't we using it right now? And basically, the entry barriers at the moment are still quite high. So you have high cost in investment of software and hardware. You have high expertise needed, like in data scientists or special developers. And also the market of AI vision is quite fragmented. So there are different approaches how to address a certain problem and different solutions and platforms. So it's not, or there's no single starting point if you want to get into the topic. And this is something that we addressed during the experiment with one explicit use case. So as mentioned, Gabler is, or we had a manufacturing company. So the manufacturing company is called Gabler and is producing automation machinery for the sweets and pharmaceutical industry. So they produce those automation machines that are very specialized for a certain use case. And so basically every machine that they are building is like an individual prototype for the specific use case. And therefore, because those are so specialized, there are a lot of very unique parts that are just manufactured for the certain machine. And with those many individual parts, the part identification in the warehouse is very ineffective because it's not economically feasible to label every part with a barcode or QR code or like with an RFID chip. And therefore, in the worst case, you have parts that have absolutely no part number, so no identifier, so that the warehouse worker has to do a manual catalog search in order to identify this part. So this is something that the warehouse worker is picking up a part and then is doing like some visual or measurement search on a computer. And this can take up to 10 minutes just to get out the part number and therefore get like the order number and where this part is needed at the moment. And also the risk of false identification is very high because there are often very small differences in those parts. And basically the frustration, because it's very ineffective, the search time is quite catastrophic and is probably also blocking the whole manufacturing process, because if a part is needed in a machine and nobody knows where it is or which part it might be, the frustration in the whole company can be very high. And basically the challenge is to make it easier, cheaper, and better. And this translates in this fields in a fast identification process. There should be as low as possible manual effort in the whole process, and you need data consistency. So if a new part is constructed, because it's very individual or quite unique, it has to be directly fed into the system or an identification system. So a high level of automation. And if we look back at the entry barriers, how to use an AI solution. So like basically the spoiler is we are using an AI application as an assistance system. And if we look back at the entry barriers, the most important part for Gabler is the high cost. So that these kind of systems are very expensive. And in this explicit use case, and also in many other use cases, this often, or the most expensive part is in order to teach the computer to recognize those objects. So the process in order to get the part into the computer that a computer can detect it afterwards is very cost intensive. And this is connected to the dataset generation. So how does a computer recognize an object? It's basically that you are giving the computer the information, how a part looks, and like the visual, appearance of the object. And this has to be done in the current state that you are just taking images of an object. So you are just going to the warehouse, you pick the part, then you're laying it on a table or something somewhere else, taking some photos, and then giving the computer the part number for this object. And then there's an AI that can learn to detect this object. But because we are dealing here with large machines, we are not talking about only one image or one part. So you have to take 100 images, for example, for one part at least. And then we have more than 1,000 parts that are necessary. And if we are taking 100 parts per image, 100 images per parts, and for the whole process, like picking up the part from the warehouse, taking the photos, and then also saving it to your computer and giving the part number information, it would take more than 800 hours to create the data set that the computer can learn on it. And there are service companies who are just providing this service to create those data sets. And basically, one such data set of 100,000 images would cost around 10 to 50,000 euros. And the 800 hours would take one person like 5 months. And this is like the basic problem that we were solving in the experiment by automating the whole process and using CAD files, like 3D models from the object in order to create the data set. And in the CAD files, all the visual information, how the part will look after it has been manufactured, exist. And also the CAD files exist for every part that is in the warehouse, since the construction of CAD files for the manufacturing at Gabler is relevant, or is like the standard since the mid of the 90s. And we, by automating the process and using the CAD files, so we are rendering images, we can nearly generate infinite data sets, so a lot larger than just 100,000 images, and therefore without any manual effort, in order to get the basis for the dataset generation and teaching the computer to recognize those objects. So if we have a look at the whole approach, before we can make the part identification more effective, we have to solve the problem of the scalability of the AI vision application. And our first step in the whole process is by rendering synthetic images from the CAD files. And in order to do it effectively and to use computing effectively, and also because we have been invited to the webinar, is that we have been using distributed computing on HPCs. And there we were able to make it a lot faster and a lot more effective. And then as the next step, the AI part identification was enabled. So this all translates into one workflow and one streamlined pipeline that generates like the detection with an automatic approach. And right now, let's have a look at what it translates into our start requirements. So with the start requirements of low manual effort, high data consistency, and the fast identification, we achieve the low manual effort by fully automating the dataset generation. Then by using distributed computing, the goal was to have an overnight synchronization, so that if an engineer is constructing or designing a new part, that it will be available for the detection process the next day. So this is the overnight synchronization in order to add new parts overnight. And then the automatic identification or fast identification is achieved that the identification process takes less than 1 second. So by automating the identification. So, and the explicit results right now was that for the 1,000 parts that we were using in this experiment, we generated a data set of 50 million images, and the data set was completely ready to be used for the AI training, and this was achieved in 10 minutes. The biggest problem that we had at this set was that we were also generating 25 terabytes in these 10 minutes, and the data or like the storage solution was a little bit tricky to achieve this. And basically, if we compare it with those service-based data sets where you have to pay 10,000 to 50,000 euros for a service company in order to give you the data set, the whole rendering process and also the training process did cost us 300 euros on an HPC computer, and therefore we had a 97% cost reduction on this approach. And the distributed computing, we were using 1,000 nodes. So for example, as Alban told us, that MeluXina has 90,000 nodes, so we still have some capacities left, but we were using 1,000 nodes in parallel in order to for each part, we had one single node in order to achieve the fastest results as possible. And therefore the full pipeline, after just generating the data sets and then training the AI in order to detect those parts, took us around 15 hours. So normally if the engineer is leaving the office at 4 p.m., the next morning the detection would have been updated and would have been enabled. But also the 15 hours is for the whole 1,000 parts. It's not like just adding one part, but it was also able to do the whole data set in one night. And the part identification was also enabled then, and reduced the search times drastically. So which resulted in higher productivity. So in the worst case, it's basically how you use the system is you just point your phone or your tablet onto a part, and then you get back the part number without any labels on those parts. And this saved several hours a day. So basically, the whole process got a lot cheaper, better, and easier, and we achieved our staff requirements for the use case to enable these applications. And by introducing and developing this kind of pipeline, an easy-to-use pipeline, we were able to, it becomes able to lower the entry barriers for many more applications, and therefore, with our approach, new applications become possible because the pipeline can be used in a lot more applications. And this is something that really transformed our product. And our solution for the high entry barriers is that right now, from a project company, we are able to offer the AI vision process as a service by giving companies access to their individual and scalable AI object recognition by using this pipeline in order to adopt AI vision themselves by just uploading CAD files and then getting back the detection. And this is implemented in one ecosystem where you have an all-in-one approach, like a one-stop shop for object detection, where you can generate the data sets, train the AI, and then also use it in applications. And this with the approach and our goal to make it as intuitive and streamlined as possible, so that an average engineer and not a data scientist or developer is able to use these kind of pipelines. And this with a very cost-effective approach, so that it becomes feasible even for just smaller applications or tools, and is available for more companies. And this is combined in one platform where we combine the training, the development, and the application side. And the workflow right now looks like this. You upload the CAD files, then you can just select or drag and drop which parts are needed for one process. And then the whole computing resources are backed up with high performance computers from our side. And you can train the AI model. And then you get also the application side, where you can directly implement the detected or like the detection models into applications, and therefore use it in different kinds of applications and test out the results. So this can be used in like basically different areas and different industries or different applications. And also what we got from as a result from it is we were able to, as like an easy to use demonstration, we were able to reduce those training efforts within one application by backing it up with like a supercomputer, where you get like the detection in just 1 minute. And they have just like one small demo where we've been training different figures of ancient Egypt in the Neues Museum in Berlin. So basically, I'm taking images right now, and afterwards, those images are fed into like a computer or an AI that afterwards can detect those objects, and the whole process just takes like several minutes, and then you get like the first results that a computer is able to detect those objects. So basically for those 3 figures, always just taking some images, and then afterwards, after I click the start training button, then the AI training pipeline is running, and after around 1 minute, those objects become detectable, and therefore like can be also used in different approaches. So this is like a side effect that we got from the experiment. Yes, and as next steps, so we launched our platform. We just launched our platform with the first test customers, and right now we are offering this kind of services for free at the moment. So just for companies and different users in order to test those benefits and if it's working for them. And therefore, if you're interested in like an onboarding appointment where we give you like a free access for 2 months, you can afterwards just book a meeting. Probably we will also send send you an email afterwards, but you can just scan the QR code, which will give you access to my calendar or like to a calendar where you can book like an onboarding meeting. And this is basically the story, how we were using supercomputing in order to transform our business and become a service company, and also offering productivity improvements for different kinds of companies.
Thank you very, very much, Lucas. It was very interesting and very fascinating also to see how you bring something as complex, let's say, as an HPC to really facilitate the job of any kind of people on the field. So in a few words, you use HPC to interact directly with the physical world, and that's really, really promising. I have a first question regarding the beginning of the pitch of Alban, where he mentioned that actually you have some time, at least, to redesign a bit of your application pipeline to benefit from the advantages of high-performance computing. On your side, did you use high-performance computing since the beginning by design, or was it something that you integrated in your pipeline afterward, and then you have been forced to rewrite or redesign part of your application?
Yeah, so basically the training from CAD files we were using before, but at the experiment we directly had the challenge that we were dealing with multiple thousands of parts. And this is something, also 25 terabytes of storage at the moment, or like in the processing step. And to feed this into a normal computer wouldn't have been possible. So basically from the beginning of the experiment, our goal was we knew that we had to use like supercomputers in order to make it really effective. And but our first development steps, so we implemented like a tool, like the generation of CAD files. We integrated this kind of building block into a supercomputing compatible pipeline.
Okay.
But the pipeline was basically designed for supercomputing.
Fine. Perfect. So, despite you have something more to add, I propose to Alban to come back on the scene, and perhaps Alban, let's do a bit of improvisation regarding the particular condition of today. Would you have, Alban, any kind of interaction, question, comment that you would like to discuss with Lucas regarding his speech?
First of all, thanks a lot. What was really interesting to see that this use case was really leveraging the power of supercomputing. But my question is a bit related to actually your question, Nicolas. Could you estimate a bit the effort that you did to move from regular computing to supercomputers? That's something I think which is really interesting for, I would say, newcomers in the supercomputing ecosystem, because that's definitely, or at least for me, using supercomputing is a strategic plan that should be like thing from the beginning. So could you tell me a bit more about the way you did to move it, and at least estimate how big was the effort to move to supercomputing?
Yes, also for us, it was so we also got like the support from the Digital Innovation Hub, where we were like designing how it should look like, as a goal. Mm-hmm. And also our first decisions when we were like how we want to develop like the like CAD models to images, like the algorithm and the AI training algorithm. We always had in mind that it should be scalable, so that it can be used in a containerized environment, basically. And therefore, it was like from the beginning we had in our mind that it should be possible to use supercomputers. Like it was like the designing process, and then the next step to really get it running into this kind of environment. We had some support just for the first starting steps, but after we had like a certain breaking point, this became quite natural. So it was working then quite good. But it helps to, even if you don't need supercomputers at the moment, it's good to have in mind that it could become possible, and that you design your building blocks compatible with supercomputers probably in the future. So because we didn't have to rewrite everything, which could have been possible if we've been using like some frameworks that are not working like in these kind of environments.
Thank you very much for this insight that would clearly bring some inspiration, let's say, to the companies that are listening today. Your pitch, Alban. I propose that finally.
Maybe I will just go directly.
Take the floor.
Due to the time restriction, I will just go directly to the use cases and the challenges.
Right. Yeah, with pleasure. Thank you.
That's something, which is okay. So yeah, there is real example. You saw the one of Lucas, and here I will quickly let's say talk about two use cases. The first one is a company which is called Monolith. This is a company based in UK, which is actually working on AI algorithms for industry. So they use and rely on supercomputers to train their algorithms. So that's AI-based algorithms, and especially reduced order model, so ROM model, to accelerate the design and the simulation from days or weeks to a couple of seconds. So here, basically, that's just an example of a wind turbine design. So normally the simulation is done with two types of numerical simulations, so CFD, FEM, so physical and numerical simulations. Those type of simulations are really, really compute intensive and required also supercomputers. But when you are prototyping, you are wasting days to wait results. So that's definitely inefficient. And you have a bunch of engineers waiting for results. So for that reasons, ROM models, so AI-based algorithms, can accelerate the simulation from days to a couple of seconds. Sure, it's not 100% accurate, but it helps you to test and design quickly potential prototypes that you will run then into real simulations. So you are reducing the number of real simulations that you will do, and then is a way to save cost. Another example is Circulion, which is an innovative and disruptive company, Luxembourgish company. So here I'm teasing a bit. LuxProvide is currently starting a collaboration with Circulion. And the mission of Circulion is to automatically disassemble the next future 3 billion battery packs for upcycling or efficient recycling of all the different components of batteries thanks to computer vision. So that's really challenging. And okay, I will not unfortunately go into details, but the objective of this collaboration is to train computer vision models at larger scale thanks to supercomputing, and then drastically decrease the number of models needed to only one single foundation model that can be used for different use cases. So here also is like getting faster time to market, but also it opened doors to cost saving. That's basically the two main applications currently. And the different challenges, let's go quickly. Basically, the first one is the money side. Let's talk about money side. So why getting into HPC might seem like a big expense. You should think of it as a smart investment. So the benefits you get from having more computing power and solving problems faster can be way more valuable than what you spend initially. On top of that, it exists a lot of support in Luxembourg that can help you to cover part of the cost. I will also talk quickly later about programs that Lux provide just released in September to support the local ecosystem adopting supercomputing. Now, about making work for your business, it might seem a bit tricky. But here, the good news is we have solution and support that Lux provide ready to help small and medium businesses through the whole process. From planning to making everything run smoothly, we're here to make it easy for you with our team of engineers. And seeing us as you guides, showing you the way and making sure that you have all the support you need. To move also to supercomputing, you need skilled people or you need training. And within Luxembourg, a lot of skilled people will be on the market really soon and even the next year, thanks to the HPC Master at University of Luxembourg. So to make it short, the whole Luxembourgish ecosystem is made to support companies moving to supercomputing. There is training, there is infrastructure, there is skilled people, and so far and so forth. So I will just quickly release these new programs and fundings. So we are really happy to share that some recent developments. So we did in late September, we launched 2 programs aimed at facilitating the adoption of supercomputing. So the first program called Initiate. So we offer credits for startups and SMEs to access and use our supercomputing infrastructure. It's our way of supporting and fostering innovation in the startup ecosystem. The second program is called Cashback 80%. So this program is in collaboration with the Ministry of Economy and with the support of Lux Innovation. And through this initiative, users can enjoy up to 80% cashback on their MeluXina usage. While Again?
Oh, you're back.
Okay.
Concerning the programs, the cashback one.
Yeah, so concerning the programs, the cashback, we just, okay. So it's a collaboration with the Ministry of Economy and the support of Lux Innovation. And through this initiative, user can enjoy up to 80% cashback on their MeluXina usage. I will not go into detail on how accessing MeluXina today, but you can find way more information on our website. Feel free to reach out by mail. We are always ready to discuss and provide any additional information you may need. That's something also we can discuss to see what can be your benefit of using HPC for your own business, right? And I think moving for supercomputing, this isn't just about like touching a new technology. It's about unlocking possibilities that can reshape your business. So basically, in other words, the journey in supercomputing is not just about upgrading your computing power. It's also about unlocking the full potential of your company. Okay.
Okay.
Yeah, if I just may,
Yeah.
I will just
No
a small analogy to explain like quickly, to think differently.
Yeah, as a wrap up, yeah, that could be interesting.
Yeah. So for instance, as an
globally.
analogy, you can consider supercomputing with a car and an aircraft. So the car is representing the regular computing and the aircraft, the supercomputing. Let's imagine you want to move from point A to point B. Those 2 points are like 10 kilometers far away from each other. You can take your car, get it in, turn on the engine, and drive directly. That's super efficient. Okay, a contrario, taking the plane for 10 kilometers doesn't make sense, right?
Yeah.
So you have to go through the check-in, security, onboarding for almost nothing. That's fully inefficient. Now let's imagine that our 2 points are not far from 10 kilometers each other, but 3,000 kilometers. You can repeat the same process with your car, but it will take a while and ages to drive 3,000 kilometers.
Yeah.
Rather than, okay, you will put a bit of time at the beginning for the plane, for instance, check-in, security check, onboarding, but then you will go way more faster to move from point A to point B. So that's the thing you should think about. Supercomputing requires a bit of time to set it up at the beginning, but on long term, the results are way more efficient when fully integrated in your company.
Yeah. That's clear. Wonderful wrap up. let's stop on this one. That's perfect, and thanks for your explanation. We're running out of time now, so sorry once again to you, our speakers, but also to our to our listeners. Just to remind you, that's not the last DIH talk of the year. There will be one yet in December. Let me get to it. And yeah, will be about predictive maintenance. So perhaps once again we could talk about HPC. But as for this one, once again, Alban and Lucas, thanks a lot, because I think that from both your presentation, we could have a very clear view of what could HPC bring to SME, and yeah, see that at the end it's not so complicated, and that it could really help to, at the end, better interact, let's say, with the physical world, the world in which manufacturing is operating, actually. So thanks again, guys, and have a nice weekend. And for all the community, see you in December. Bye.
Thank you. Bye, everybody. Nice weekend.